This video, I'm showing you the notes on how to graph a translation of tangent. It's very similar to the translations of sine and cosine. The only thing that's different really that I want to point out is the period here. Notice that they're dividing by pi. And the reason being, if we take a look at our tangent function, the period repeated every pi, right? From here to here, that whole thing repeats every pi. So we have the period. We take pi and divide it by b if there's a b term. B is the exact same as it was in sines and cosines. Our domain is all real numbers where x is, and then what they did here is they created this like formula, and what they're doing is they're creating the asymptotes that we saw in the last video or the picture I just scrolled up to. Those asymptotes would come out just like that. I like to think about it a little different. I'll find the domain of this next one, of the one we're going to graph, to help with that. This is the exact same formula for that. The range, the tangent function, if we go look again, the tangent function goes up forever and down forever. So the range makes sense to be all real numbers. Okay, so we have all real numbers. Sorry for that scroll. And then we also have tangent being an odd function, and that's because inputs, opposite inputs give us opposite outputs. We can see that here right in the middle, right? This and that have opposite inputs, but opposite outputs, so it is an odd function. It is symmetric about the origin. All right, we're going to graph one of these. The functions here, I'm going to scroll down because the way that it ended up printing out, the graph's on the next page. So that's what we're going to graph. So again, like in the last one, I like to find everything that we need. Okay, so we can call A, the out front number. We'll call it amplitude, even though it's not really an amplitude here. But I'll show you what I do with that to find that value. And then also I see that B is pi over 6, which means that the period is, we take the original period of pi, which is pi, and I divide by pi over 6. And we're going to flip that over, and I'm just going to get a nice pretty 6. So the period for that is 6. So instead of a like pi over 2, a negative pi over 2 to pi over 2, and that being the length of pi, I need the whole period to be a 6, which means the asymptotes are going to happen at 3. So I'm going to cheat here. Instead of doing that, I'm just going to change it to a dotted line. All right. Duplicate that. So we have it there and at 3. So you can see now that we have 6 across, right? 3 on each side, and we know it's right in the middle. Okay, and then I'm going to duplicate that again because I got to go sit. Can I fit 6? I'm at 3. 6 would be like 9 out here. We'll do that. Sure. And then we'll duplicate one more time, and might as well do it on the other side. Cool. Okay, so we also, that takes care of this part, right? That's 6. And then the amplitude is 3. So this is how I do that, how I use the 3 is, okay, I know I start here at 3. Now usually, if I go back up, and I'm going to scroll for a moment to see this trig function, usually I would go over halfway to my asymptote to get there and there. And that's usually a 1. So I'm going to use that idea that I'm going to go halfway between the 0 and the asymptote, and I'm going to put the amplitude, quote-unquote amplitude, the A, distance up and down on both sides. So going back to our graph, okay, cool, A is 3, so I'm going to go halfway. Okay, halfway at 3 is 1.5, that's right here. You can see it geometrically as well. Right here this way. All right, and I'm going to go up to 3. So I think each one of these are 1. So I plot my 3 there. Oh, I missed a line. There we go. And then down here, I'm going to go there as well. And that's what I use as my graph. I don't really come up with the other 2 points around those. I just know it's going to look something like this. Right? And then we're going to take that, and you would copy it again in each side here. And then we'd put it on the other side as well. Cool. And that would be our tangent. If they asked us to graph one period, we would either graph, this one here, right? That's the one I usually go with for one period. And then some curriculums, they may give you the graph and say put it there. like we first came up with our table. I like the full picture of tangent coming from this. better than splitting it by an asymptote, but that's just a preference. All right, I believe that is it for this one. Okay, so now we're going to work on cotangent.